recent Penn State research highlights, some of which some of you heard from Laura this morning, but they're definitely worth repeating. After that, we're going to hear from 3 industry partners, and finally, we'll have a set of faculty lightning talks. So in a 2019 study published in the Journal of Higher Education, a group of researchers from UC Riverside assessed the effectiveness of interdisciplinary programs. They looked at 80 major universities. They ultimately assessed 20. They determined that Penn State was the only university that created and nurtured interdisciplinary research effectively, and that the 7 Penn State-wide institutes were fundamental contributors to this success. And in case you're guessing, ICDS is one of those 7. Another illustration of the breadth and excellence of Penn State research can be drawn from the rankings of research expenditures, the amount of investment in Penn State research in the context of the US research community. Penn State ranks in the top 10 universities in 18 different research fields, ranking in the top 10 more often than any other institution. And as Laura said this morning, this analysis isn't restricted to a single funding agency. So it's not restricted to an individual research domain. So we have the breadth and we have the excellence. And in the last year, Penn State exceeded $1 billion in research expenditures. And as I said, this illustrates our astonishing breadth and depth of research achievements. And of course, more and more, computation and data sciences are a critical component of research across all domains. Now, this year, we've asked a few of our industry partners to share their perspectives on data challenges they face and how they're combating those challenges. And Joel, are you speaking first? I have Bill Higgins.
Hey, Jenny, I am not speaking. For some reason, Bill came up under my name, I think because of the invite that was sent to us. But Bill Higgins is on, and he will be speaking on behalf of IBM. Bill is an IBM Distinguished Engineer and a Penn State alum, and it's my honor and privilege to introduce him. Bill, you there?
Yep, can you hear me?
Great, yes, thanks, Bill.
So despite what Zoom might say, my name's actually Bill, not Joel, though Joel's a great guy. And let me try to take over the screen here if that's cool. Where is PowerPoint? So yeah, can somebody confirm that they can see my screen?
Definitely.
Yep.
Okay. And is it big now?
Yes.
Sweet. All right. So I went to Penn State from 96 to 2000, back when AI was considered an interesting research topic. But as we all know, around 2010, 2012 or so, there were a number of breakthroughs that happened with cloud computing, with the explosion of data, with some advancements in algorithms that made it practical for the enterprise. And so what I thought I'd take you through today was the IBM perspective on organizational transformation via AI. So it's not going to get into like what's the next best NLP algorithm or something like that, but rather what do the companies of the world and the organizations of the world face as a challenge when they think about wanting to actually transform their businesses with AI, and what's the kind of the conceptual framework backed by technology that we're sharing with them to help them deal with that massive challenge. And I know that a lot of you on the call are researchers, but I thought this would be interesting to you, or I hope it's interesting to you, because I think as you're talking to these companies about what would be interesting research, it might be tempting to like say, you know, we're going to work on this next deep learning algorithm for you. But the challenges they face are kind of, in some ways more complicated, but in some ways more basic than that. So anyway, I'm going to go through it. And at the end, there's a book that we did with O'Reilly, which is a lot more info, but I'd love to talk with folks who are interested in talking more. All right, so so right now there's this huge desire to have businesses get smarter. As companies see other companies adopt AI, the pioneers, they realize that right now they have a chance to differentiate with AI, but it's quickly becoming table stakes. And so if they can't move quickly, they're going to get left behind. Also is the topic of resilience. So resilience is about adaptive capacity in the face of, an ever-changing environment, and how do we reduce systemic fragility. And COVID-19 really brought this to light, where companies who hadn't made past investments in resilience are paying the price now. So those are the two things we're really seeing, that sort of desire for more intelligence and greater agility through intelligence, and the desire for greater resilience. These are kind of some of the big macro problems that people are facing. I'm not going to go through these in detail because I think we all kind of know these. But the big point is that each of the little phrases on this chart by itself is a really hard problem. And right now, companies are facing all of these simultaneously. So what we believe is that going forward, IT will be decentralized, open, and secure. Automation will fuel the future of work, and winners will scale the value of data and AI. So what we're saying is that companies who do these three things well are going to have a chance to succeed. Those who don't do it well are going to get left behind. So now just a little bit about resilience. So what we've seen in the past, let's see, how many months since March? 7 months has been companies have had to kind of pivot overnight. Transformations that they had expected to take place over the next 2 to 3 years, they had to make happen in the course of 2 to 3 weeks. And so everybody's kind of in this state of upheaval, and they've realized that they just have to accelerate things that they previously thought they could do gradually. And it's actually driving, fortunately for us as a company who's an AI vendor, we're actually seeing people actually try to go after AI faster, not because it's cool, but out of necessity. Like when COVID hit, one really concrete thing that happened was call centers that had previously been staffed by 500 or 1,000 humans in the same place had to go virtual literally overnight. And so that drove a lot of demand for chatbots, because all of a sudden they lost a bunch of human capacity all at once. And so what we're seeing is this big acceleration towards AI because of COVID and other disrupting forces. So no surprise, everybody's on this path to AI, again, not out of coolness, but out of necessity. But here's one of the problems. People have been dealing with electronic data since computers began in the 40s. But in terms of maturity towards AI, people are in general relatively immature. So people are pretty good at transactional systems and to some degree BI and warehousing, but people are very immature when it comes to predictive analytics and actually transforming business process through applied machine learning. And so, I think a lot of the research community is always trying to think about how can I make a better algorithm or improve efficiency. But the thing you have to remember is that you're kind of talking about running faster, and a lot of the businesses of the world are thinking about going from crawling to walking. Oopsie, sorry, I skipped a chart. So these are the three things that we see are the hardest problems in terms of going from AI as an aspiration to AI as a deployed reality that's giving you competitive advantage. The first one is the data is a mess. We all know that data is the fuel of AI, but in most modern enterprises, they have literally thousands of data sources fragmented across many different data centers and many different data architectures and underlying technologies. Talent, the skills are rare and in high demand. I think no surprise there. And then the other thing is trust. So it's one thing when you're doing AI for Netflix recommendations. It's a very different thing when you're doing AI for approving a loan application. And some of the advances in AI with deep learning have also brought about increased opaqueness. And so it's making it hard to adopt in the enterprise. Let me jump forward a little bit. So this is the title of my talk, The AI Ladder. So when we talk to companies, this is the conceptual framework we use to help them think about how to get from here to there. So you're a CIO and your CEO says, you have to embrace AI, you have to adopt AI. Fortune magazine said I had to. How do you get from I've got 10,000 databases to I'm transforming business processes and user experiences with AI? So this is the AI ladder starting from the bottom. So collect is, how can we start to harness the fragmented data and start to make it pooled, normalized data, which takes us to organize, which says, okay, if I've got a bunch of redundant data sources, how do I normalize them, make sense of them, have a master data management scheme? And also, how do I govern the accessibility of that data and the security of that data? Because as you bring everything into a big data lake, it becomes a much more attractive target. Analyze, this is about once you've got that data together, how do you actually get value out of it, both through understanding with inference and making decisions with inference and prediction. And finally, infuse is how do you actually change business processes? And just understand the difference between analyze and infuse as an analogy. So analyze, think about Blockbuster Video in the 1990s for anybody who's old enough. They probably had analytics to say we should send more copies of Ghostbusters to Pennsylvania and less copies to Oklahoma for whatever reason. But it was a batch job. It was a monthly thing. It wasn't part of the business process. Whereas if you look at something like Netflix, every single screen you see is being optimized for your preferences by understanding what you've looked at before and analyzing your attributes versus other people who are similar to you. So it's about really bringing it online, changing experiences, changing business processes. So this is kind of, let me jump past this chart. So just to talk about the approach we're taking to it, and don't really pay attention to the products so much as what's on the left with the capabilities. So these are sort of the logical things that you have to do in order to climb this AI ladder. Of course, IBM provides products for that, but the goal of today is to more talk about the conceptual framework. So in terms of collecting and organizing, how do you eliminate data silos? How do you work across clouds? Because companies are always split across both different clouds and on premises. How do you automate and govern the use of your data such that you can make it self-service in a safe way so that the people who should have access to the data can quickly get access to the data, and the people who maybe need access to the data can get access in an auditable way. Then in terms of the AI lifecycle, so this is about, we've started to organize our data. Now we want to start to create our own models such that we can start to automate the business processes. We can provide better insights and predictions for customers. So the approach we're taking is a combination of tools for basically data set management and then tools for building custom models. And one of the big enabling technologies for us here is Auto AI. And if you're not familiar with Auto AI, though you probably are, it basically helps you with the process of looking at the performance of different AI algorithms. As we all know, there's been this explosion in innovation with AI, but one of the downsides of that is that you actually have too many choices in terms of what AI algorithm might I use, and there might even be ones you've never heard of. So with Auto AI, it actually tries to do some introspection on the data and the outcomes you're optimizing for, and then help you discover an algorithm that might perform better in an automated way, and also help you discover ones you might not have known about. Then the last thing I'm going to talk about is about AI applications. And this is, I think for me, this is kind of an interesting one. So you folks who have PhDs in data science or machine learning or statistics, it's all great, you know what you know. But what we're trying to do is bring your expertise and make it accessible for people who don't have PhDs in machine learning. So for instance, with customer care, you think about chatbots. How do you help somebody make a great chatbot? Well, the person who really understands what great customer care looks like doesn't know what AI is other than what it stands for. And so what we're trying to do is package up AI models and then make them accessible to an audience through pre-built tooling. So I think one thing you can think about from an innovation perspective is how can you make AI geared towards some domain, whether it's like an industry like insurance or finance or travel. How can you make that more accessible to a business user who can't possibly learn all the things that you've learned? So I think this is an area ripe for exploration, because right now AI is powerful, but it's largely inaccessible. And then let me just jump to the last slide because I want to be respectful to other folks' time. So I know I've been talking super fast and covering a lot of ground. That's a rapid fire view of how we think about AI-driven transformation. Last year, we started work with O'Reilly to package this up in a book. And if you want to read the more detailed version of this, I recommend you get this book. It's available for free with a little bit of personal information. And it goes into great detail about all phases of the AI ladder: collect, organize, analyze, and fuse. All right, I know I was talking super fast, but there's a lot of material to get through, so I'll stop now. I don't know if we're going to do questions.
Thanks very much, Bill. I'm not sure if we will have time for questions, but let me go back and just say to everyone that Bill's a distinguished engineer with IBM's Watson AI platform, a leader in IBM's AI platform efforts, and responsible for the evolution of the core Watson language platform. So you've probably guessed this is his fundamental expertise, but I did want to give that perspective. And just one more thing, Bill made a great point about resilience in COVID. At Penn State, we were tasked with going fully online in 4 days, and our central IT pulled it off without a hitch. And I also want to give a shout out to the ICDS team. We went fully online, and this change was invisible to the users. And almost immediately, we had a 10% increase in usage. So I think the team did an amazing job and kept delivering. Now I'm very pleased to introduce Thierry Pellegrino, who's going to present our second talk. You can see democratization of HPC AI. Thierry is Vice President of the Data-Centric Workloads and Solutions Organization at Dell EMC. Thierry graduated from Penn State in 1998 with a master's in EE. A 22-year Dell veteran, Thierry's an experienced executive with a background in engineering, go-to-market, technology, M&A, and strategy. During his tenure at Dell, he led the first Dell converged infrastructure product, assembled the global OEM custom engineering organization. He was in charge of technology strategy for the merger between Dell and EMC, and now has responsibility over the global HPC business for Dell EMC and the business strategy and transformation for the overall $20 billion plus server infrastructure solutions group. Thierry has truly got global experience, born and raised in France. He speaks 5 languages, and he has spent the last 22 years, I believe, in Austin, Texas. So thanks, Thierry.
Thanks, Jenny. Thanks for the intro. Good afternoon, everybody. And I would have loved to be on campus today and remember those fantastic days of early or beginning of late fall in Penn State. But with COVID, we all have to adjust. So as Jenny stated today, I want to talk about this tongue twister, the democratization of HPC, at least the way we see it, and how it relates to what you're discussing through this symposium, the data deluge. And as you can note from the title of the organization that I lead within Dell Technologies, the data-centric workloads and solutions, data is really at the core of all of the workloads and solutions that all of us really are working on and trying to help make advancements on. So just by way of starting the talk, I wanted to talk about some of the industry trends. And you all see that as you try to understand the infrastructure on which you want to run your research and find the next big discovery. There are a lot of innovations going on in the industry in technology. And the basis of the rest of the discussion will be how complicated it's getting. There are innovations in memory, in drives, in accelerators, and quite frankly, when a lot of the high performance computing and artificial intelligence was really based on compute and accelerators, now that proliferation of the different types of compute, from x86 to ARM to even RISC at some point coming back for some embedded applications. And on the accelerator side, NVIDIA's dominance, AMD coming back with some very competitive products, Intel getting back into the game, and others. This is becoming an innovation that we all want to be benefiting from, but pretty complex to understand, especially when we put all the pieces together. There are more and more organizations looking to use AI, machine learning, and deep learning to get better business insights out of their data. You know, Jenny talked about the fact that I was part of the merger between Dell and EMC. You can put 2 great giants together, EMC with a fantastic storage portfolio, And we'd love to be putting a lot of data on storage, but after a while, when we talk about zettabytes of data, it's not feasible to put all the data in a locker. It could make EMC very successful, Dell EMC very successful, but the value is really into getting the insights from the data. And then the last thing is, how do you optimize those systems? We had a talk earlier during the product briefing discussion, and we were describing how it's not so much understanding the technology, it's understanding that translation from the technology, the features and the performance characteristics of technology into the real life workloads of a genomic type of workload, or an industrial automation workload. And all this takes a lot of years studying those spaces. And that's one thing that really needs to come together to unlock the potential of this innovation that we see. And then the quiz that we ran through a Computer Weekly research article was how many customers out there, how many folks in IT out there believe that HPC is important. And the number came back, not so surprisingly to me, but maybe to others, about 86% of IT professionals surveyed from all different walks of life felt that HPC was important. And this is understandable. Parallelism is how you get better performance in order to, in research and academia, get further in discoveries, but also in the enterprise world, get your business processes handled more directly and more in line with your business. So the other thing that I wanted to cover was the proliferation of the subsections that make out the whole HPC world. Traditional HPC is what you see on the left, and that there was modeling, simulation, application, and that's what most people back in the 90s thought was the definition of HPC. When we get to today, we have now high performance data analytics. We have data-centric HPC applications, AI, but also this new wave of HPC and AI as a service. Just tying the dots from the previous topic of complexity, if the complexity is such that it takes, no pun intended, a PhD in technology in order to do your PhD in a different science, it's not really going to help promote advancements. So more and more customers and institutions are looking for this HPC and AI platform as a service. And this is one area that will be interesting to explore. When I look at the strategy for what we want to provide as a value to our customers in HPC and AI, we categorize that in 3 different buckets. The first bucket would be advancing HPC. The second one is democratizing HPC. The third one is optimizing HPC. And today I'm not going to spend much time on the first and the last one, but I wanted to spend more time on this democratization because I think it's a more noble way of thinking about how we can take care of this data deluge and turn it into value for all of us. The piece about democratizing HPC starts with that complexity and the fact that we want to be able to get to answers faster. And in any model, how do we get answers faster? Not by having just one person or one company or one technology vendor focus on that innovation by itself. The way we go faster is by creating a collaboration, making things simpler. And that's a big part of what we attempt to do in the way we provide solutions in HPC and AI is we break it down into simple, validated solutions that can be useful on day one. Not a science project to go figure out the best components to put together. We've taken care of all this. And this allows everybody to get to their value faster. So time to research is shortened, time to discovery is shortened, time to business value for the enterprise and the industry is shortened also. We also, in order to democratize HPC and simplify it, we break it down by domain-specific activities, not just a big horizontal view, but very specific value adds for the different domains: manufacturing, healthcare, finance, and others. And then the last piece is the confidence that whatever has been democratized and put together will work from the get-go. It's validated, it's good to go. The other thing that we feel is really critical, and I alluded to it already, is this community spirit. How do we all together as a big HPC world collaborate to make progress? So we for the past 4 years have had a very successful event that takes place 3 times a year, where we bring our partners, our technology providers, our customers, and a lot of the PhDs and smart fellows for the company themselves together in a collaboration forum. And if you don't participate in those, I would encourage you to register. The hyperlink is here on the list. As I finish the update today on this democratization, I also want to bring up another opportunity to collaborate, all of us. We have an HPC and AI Innovation Lab in Austin, Texas, and we open up direct communication between faculty, researchers, and our own engineers and PhD students in the lab to try and solve problems real time. You don't have to go and ask for permission. We have this approach of the discussion needs to take place. We are here to help. And if you have a problem you can't solve, don't hesitate to reach out to us. And as I finish the talk, what I want to finish with is by democratizing HPC, we get to a point where even the biggest systems in the world, and Frontera is one that you see here on this one slide, and then HPC5 is the second one. You can create some of the top 10 supercomputers with standard building blocks. You need to understand how they come together. That is the science and the advantage that a partner like Dell can provide. So if you want to know more about the details of all the technologies we bring together and how we can engage with you and create this forum of community sharing, some of the links are here on the slide. But I'll be available, and I'll make those slides available to the folks that are here on the call today.
Thank you, Thierry. And now I'm shifting gears so we can keep to time. I'm very pleased to introduce Kam Syed, Senior Manager leading the Research Business Development Team at Amazon Web Services, AWS. Kam's team is responsible for working with federal agencies and research institutions to build solutions that help researchers accelerate their time to research. So Kam's been with AWS for over 8 years and has held multiple roles, including business strategy leader for AWS Cloud Storage Services and establishing the EdTech vertical. Kam has 20 years of experience in high-tech industry and has worked across various verticals, including education, healthcare, manufacturing, media, and retail. He's a global executive who's worked across US, UK, Middle East, and India. He currently lives in Seattle with his wife and kids. Kam has a degree in computer science and engineering from the University of Madras and an MBA from the University of Wales in the UK. Thanks, Kam.
Thank you, Jenny. Appreciate the opportunity. I just wanted to make sure that you guys are seeing the right screen, or are you seeing the presenter's view here?
I think we're just seeing the screen itself. Oh, no, we are seeing presenter's view, sorry.
Okay, there we go. I just wanted to confirm. Sometimes
there we go.
Okay, you can see it well. All right. Appreciate the introduction, and love to see the PSU alumni here, both Thierry and Bill. Unfortunately, I'm not a PSU alumni yet, but eventually one day I'll come to PSU for my further studies maybe, or my kids would go there, but love the university. Today, next 10 minutes, I know this is a quick lightning talk. What I'd like to focus is bring the audience into views of what we at AWS are seeing with the data growth and expansion, or explosion, if you will, and the innovations that we are doing on behalf of our customers, and give you a quick peek into the technology that's fueling this innovation. So this will be the topic for today. And as you all have seen, data has now been the lifeblood for many researchers and businesses. traditionally, even at Amazon, we've become good and better at building complex applications and systems. But what we are seeing is we are seeing the rise of massive complex systems now built around the data. And this is the time for modern data architectures. And the reason why modern data architectures has become so crucial is because of the explosion of the data and different personas within just an organization or research institution. The same data set could be used by different people from a different point of view. So this is driving the demand for a new data architecture. And also there is the businesses that are asking for quick real-time decision making. Companies are moving from traditional data siloed model, which was built a number of years ago, to a data lake model where all data is pooled into a single large, whether it is structured or unstructured data, just pooled into a large data set that can scale horizontally for various use cases. And by far, within AWS and even outside, what we are seeing is the most popular data store for data lakes infrastructure is S3. And here's a quick background into what Amazon S3 is. Most of you might be familiar with this, but in case you're not aware of it, Amazon launched S3 in 2006, and this radically transformed the IT universe. S3 has now become the de facto industry standard to store data using just an API. Exabytes of data is stored at AWS by over 2 million customers of ours, which tells you that the storage environment or the infrastructure that is behind S3 needs to be adaptable. It needs to be scalable. So the way we approach our journey in this technology isn't threefold. How are we building the infrastructure that is supporting S3? What types of innovations are we doing, both in terms of security, making sure that the data, once a customer stores it in the cloud, it is secure, it is encrypted, it is transmitted with encryption, both at rest and in transit, it is always available. We guarantee 7 nines of durability there on the data that is stored, highly performant, and also making sure that we are running our operations in a cost-effective way so that we can share those savings back to our customers. Amazon has a culture of frugality. We are frugal in how we drive our operations, and we use technology and automations to bring the cost down for our customers. And at AWS, we've lowered our prices almost 68 times now, and always making sure that we are transferring the benefits back to our customers. From an architecture standpoint, we know that moving to the cloud is a key enabler for a lot of our customers. So, and we also know that there might be certain data sets that might not be ready to move to the cloud. So investing in the innovation at the edge has been a priority for us for the last 5-6 years. We've been doing a lot of innovation in the field of edge computing, and I'll walk you through some of the innovations there. And finally, this investment that we're doing both in the field of infrastructural innovation and architectural innovation is focused on making sure that the culture of innovation with our customers is also changing. They are adapting to this customer, making sure that more experiments are done with low cost of infrastructural residual there. That's been the focus for AWS over the last few years. And this is all feedback that what we've got from our customers to drive innovation in these areas. IDC reports have said that IT infrastructure teams will realize an average of 62% more efficiency, and application developers will see 25% more productivity by moving to the cloud and conducting their research in the cloud. And to just dig deeper into the technology stack, we know that customers do not need one type of storage. They need a variety based on their use cases. Whether it is an object store, AWS has Amazon S3. If you are working on high throughput transaction intense workloads, we have Amazon Block Storage for you. If you have an environment where you need to share files and distribute it in a traditional format, Amazon has options for a variety of file systems for you. So this provides you the most complete storage portfolio. This is just the basic storage. Again, the same analogy of Amazon.com, where we have a broad selection of products for our customers, is what we've inherited within AWS as well. And if you look at our database services offering, we have a variety of databases so that researchers can perform the kind of research based on the data set that they're working on. An area that I touched on was about the edge computing, but we also realized that moving to the cloud is, people traditionally thought, okay, let's use the best cable, 10 gig pipe to move the data to the cloud. We thought that that was sufficient, but we were surprised when customers came back to us and said, we have petabytes of data that we would like to move to the cloud. So we invested in innovating that particular frontier for our customers by launching devices called Snowmobile, or the Snow family, Snow Cone, Snowball, Snowmobile. Snowmobile is actually a giant truck that comes to your data center, where you can plug it to your truck, plug this truck to your data center and transmit all the data so that you can now bring life to the data in the cloud and perform analytics there. It is also connected to, a recent innovation that we've done in the field is called AWS Outpost. AWS Outpost is like AWS brought to your data center. We realized that some of our customers work with really low latency data, low latency, models of data access. And some of these could be high intensive workloads like edge devices or edge computing, or even around medical imaging. So those devices need the data to be really close next to you, even for medical imaging. So what we did is we brought AWS Outpost as cloud in a box for you in your data center. It is a fully managed environment, a 42U rack that is helping you plug your data set, plug this box into your data center, and you can now leverage S3 there. You can have access to all the compute. You pay for what you use only. It is a fully managed environment. AWS manages the security of the cloud. What is in the cloud is your responsibility. How you manage with the security keys that you provide, all that environment is capable for you, is the capability that we offer it to you. And this is a look of the AWS Outpost rack. It is live and available now for you to order. And we are seeing customers like the National Geospatial Intelligence Agency using all these Snow family devices in Outpost to transmit tons of data that they are gathering from the ocean floor, from those offshore rigs to the cloud, and performing analytics around it. S3, as I said, has become the best place for data lakes. It doesn't matter where you're bringing this data from. You can access this to all your periphery services that AWS offers, whether you want to conduct your next machine learning algorithm, machine learning analytics, or you want to do your quantum computing with Amazon Bracket, the newest service offering. All these services connect back to Amazon S3, making it the center for your innovation there. It is, we've kept it to ensure that it is scalable, it is cost effective, and it has the broadest ecosystem of technologies around it, so that your next modern architecture is not only where you are today, but where you go in the future as well. Another example that I'd like to share is one of our customers is NIH, the National Institute of Health. They have started working with cloud service providers like AWS to foster innovation in the biomedical research. And one of the reasons why they started working with AWS and other cloud service providers is to benefit from this ecosystem and to make sure that the data that is being collected by researchers, it is easily shareable, it is user-friendly, and also they, as a federal agency, are leveraging the tax dollars in the most prudent and sustainable way. Just since the launch of this program in 2018, NIH has stored over 80 petabytes, run over 30 million compute jobs, and has saved over $8.5 million by running this environment in the cloud. So that's just a quick story there. And the overarching takeaway I'd like to leave with you is we are living in an age of infinite leverage, whether it is your needs for your compute, your storage, the skill, the capital, or whatever. You just have to be smart at making decisions and At Amazon, we always work backwards from our customers, and we want to make sure that we continue to innovate on behalf of you and offer these services back to you guys. A couple of programs that I think we touched earlier during the product talk, but I want to reiterate is we have the AWS Open Dataset program where researchers can bring in their open datasets, share it with the community. There are over 200 datasets that are already available there. And out of 200, I think 60 of them have been just published by NIH in this open data program. So that's an area where you can go. We also have the data exchange where you can monetize your data if you wish to monetize it as well. We have third parties who are uploading the data and selling it for a fee. So that's another model. We also have data egress waiver program for education institutions and a special pricing program for storage for researchers, including the cloud credits program for researchers. I think, with that, I'd like to wrap this up. There are several training tools that are available, lots of blog posts and documents for researchers around AWS. Research has been a focus area for us for many years. We just, accelerating our focus here now. And this is a place, if there is one place you want to go and learn about all things AWS, is the aws.training.com. You have access to a lot of free digital content, especially around storage, 45 plus free services there. And I think, the next steps for you guys would be to just start up. I think PSU is already a great customer of ours. We'll continue to support you here, Jenni. And if there is anything else that we could help you with, just let us know. I think, this is the final closing note. I think innovation is closer than you all think it is. So let's keep the engagement going. Thank you. I appreciate the opportunity.
Thank you, Kam. And many thanks to our three speakers for their diverse perspectives: Bill Higgins of IBM, Thierry Pellegrino of Dell EMC, and you just heard Kam Syed of AWS. Now I'm going to hand over to Todd Price for the rest of the session. Todd is the ICDS Corporate Relations Director for Research. Todd arrived at ICDS a week before the lockdown, but he hit the ground running and has been doing a great job since he arrived. So thanks, Todd.
Great. Thank you, Jenni. I appreciate it. As Jenni had said, my first day was the week before we were supposed to originally meet, so I'm glad to finally be here. I started that Monday, and then Friday they had me pack up my office, and I've been working from home ever since. But in terms of today, it's been a long time coming, but I'm very proud to be able to get into our faculty lightning talks. Ryan Antian, who is one of our technical leads and one of the smartest people in our office, is going to be helping me out. Ryan, if you want to move ahead in the slide here, we're going to be getting into 10 faculty talks today. And again, a big thanks to AWS, IBM, Dell, also VMware and Intel for sponsoring this event to make this happen. Ryan, if you want to get the next video set up, we've got 10 researchers that are going to be giving quick overviews on what their research is. I'll be getting into a little bit of it beforehand, but we're going to let the researchers do the talk. So Ryan, you can let this one go, please.
We can't hear.
Sorry, give me 1 second here.
Hello, my name is Jean-Paul Armache, and I'm a faculty member at the Penn State University at the Department of Biochemistry and Molecular Biology, as well as an associate at ICDS. I'm here today to tell you about our project, which we call WebSci, which is a platform for incorporation and visualization of various scientific sources using AI in a multi-layered, web-based approach. Our laboratory uses powerful electron microscopes to study important and challenging targets at near atomic resolution. We're currently aiming to explain the molecular basis of the SARS coronavirus to reproduction in human cells, elucidate the nuclear DNA packaging and maintenance that is important for the cell to avoid turning carcinogenous, as well as signal transduction critical in human reproduction. We are also devoted to methods and software development that would benefit the scientific community. A while ago, we realized that an expert in one field might not be equally expert at reading data from a complementary field. An example of that would be myself. An expert in cryo-electron microscopy and structural biology, I do not truly comprehend genetics or medical data equally well. Thus, I cannot tie it with my research in a proper manner without seeking collaborations or interpretation from my colleagues. The same happens across every branch of science. Due to the abundance of published data and interpretations, it has become a challenge to find and understand information across different fields. Oftentimes, it is actually the search through the known that takes the most time. Here, we propose to develop a smart, web-based platform that would allow for data incorporation and visualization in a simple, readable form, made understandable across the fields, independent of the user's expertise levels. Using a multi-layered visualization approach, akin to how map apps on your phones display information, we would connect information such as 3D structural data, bioinformatical sequence alignments in representative organisms, as well as information harvested from available biomedical publications using natural language processing, such as chemotherapeutic data, mutation and disease information, and others. This would allow for an unprecedented speed up of research, critical in cases such as response to coronavirus pandemic, by providing everyone with an easily understandable and easily approachable data tied with the past research and information across the fields. In the future, any data could be added to the platform as a new layer. Using this approach as scientists, we would be able to tie the relevance of our research with existing data through the use of advanced AI procedures, identify the most crucial information as well as the blank spots on the knowledge map. The risks here involve getting overflooded with the amount of information we would want to parse through, which we would simplify first by focusing on specific targets and only then expand the scope. We have already identified the best approaches of the visualization, but would greatly benefit from the UX UI expertise, AI expertise, as well as funding. Thank you very much for being here. Have a good day.
With each of these presentations, obviously we're going to be having a video talk, and you can see a quad blocker research piece. We just came from the Eberly College of Science, and as we move forward, the one thing I really want the audience to see, and the great thing about ICDS, is how we bring forth everybody to the table. So when we look at problems, it's not just a singular organization that we're working with, a college or a department. We really are bringing everybody in. Ryan, if you want to go to the next slide, we now look at going from a chemical application into a biomedical piece. So Ryan, why don't you start, please?
Hi, everyone. My name is Larry Cheng. I'm an assistant professor in engineering science and mechanics at Penn State University. And today it's my pleasure to share our recent work on the biodegradable tattoo-like sensors for biomedicine. In a nutshell, we have been working on the sensors to capture the biomarker from human body and also from the exposed environment to inform health condition. And we are going to focus on the wireless and powerless data transfer capability. And that's really something quite useful. So that will have the integrated system for the invasion application. And in this particular demonstration I'm going to show tonight is going to have the focus on ultra-sensitive detection of the ultra-low limit of detection for the gas molecules and the other things alike. And in this example, let me turn on my laser pointer so that I can point it out. And here, by using commercially available CO2 laser, we're able to convert the polyimide thin film into a porous structure like graphene foam, and that allows us to integrate nanomaterial for gas-sensitive application. And because we can also do the coating of silver and the other wires of nano metal materials in this location, so we'll be able to reduce the resistance and localize the heating effect in the sensing region. And we can either disperse the nanomaterial afterwards or
It looks like we have a small audio issue happening here. The one thing I wanted to let everybody know, and that's going to happen afterwards, is each of the researchers, or most of the researchers, are going to have individual breakout rooms. So as we begin to set up what these pieces are, there's definitely going to be a piece where you can connect with the researchers afterwards, should you have more questions. As we look at Dr. Cheng's, basically biomedical pieces going onto a body, there's obviously more than a 3-minute piece that can explain what that is. So afterwards, we're going to have individual breakout rooms that you can go in and interact with some of these faculty members. Ryan, did we fix our issue?
Yes, that was a power blip on my end. Sorry.
All right, then.
Or we can apply the nanomaterial precursor to convert that into a nanomaterial directly. And this is compatible with the other modules, so we can actually fabricate not only the gas sensor, but also the other sensing modules, and also even the wireless communication module, for example, antenna, near field communication. And by coupling antenna with a rectifying circuit, we can even result in energy harvesting device to harvest ambient RF energy, and all of this can be fabricated on a 3D shape like the glass beaker. And this is something we are envisioning for the future, not only on the human body to capture the biomarker from the human body, but also to enable the smart Internet of Things, so that I will be able to capture all the information and communicate among them. So this is our research, and I guess I will just stop here due to the time limit, and thank you so much for your attention. And I know I probably skipped a lot of detail, but my contact information is on the slide, and please feel free to reach out to me if you have any questions. Thank you so much, and bye.
As we move forward, the one thing I want everyone to hear is that with ICDS, we don't believe innovation always happens within a specific college or department. Sometimes that innovation happens in between areas. So as we look at Dr. Gonda's presentation coming up, and Ryan, you can move ahead to the video, we're looking here not only at biology, but how also that works in with a specific institute. So we're talking institutes to institutes, colleges to colleges, again, bringing all the right people together to make sure that innovation happens. Go ahead and play there, Ryan.
Hi, my name is Erica Ganda. I am an assistant professor of food animal microbiomes here at the Department of Animal Science at Penn State, and I established my lab here not too long ago in July of 2019. So the focus of my lab is to use next generation sequencing technologies to provide solutions for the agricultural industry. I have a background studying the milk microbiome upon experimental and natural infection with E. coli mastitis and the use of third generation cephalosporins, which are antibiotics, and seeing how that changes the milk microbiome. But here at Penn State, we have expanded the number of species we work with, and we have projects that are focused on poultry, bovines, and we are also looking into some swine work. So the main focus of my lab is how can we use these types of new technologies while keeping a One Health focus to help farmers improve their animal health and productivity. So some of the key challenges that the industry faces right now is we are not able to feed antibiotics as growth promotion. This has been outlawed in this country. So if you think your food has antibiotics in it, it's not true because it's illegal. However, we lost feeding antibiotics as a tool to improve growth promotion. And I believe that the microbiome can be a very good replacement for that. So that's one of the major areas of research in my lab, as well as the evaluation of probiotics and nutraceutics. And in terms of big data, what I really want to do is to develop a microbiome-based approach to improve decision-making, in improve productivity and animal health. So for example, can I get all this microbiome and big data and make an algorithm that when I look at the profile can tell me, oh, these animals are going to do much better if you give a sorghum protein source versus a soybean protein source, or these animals were going to do much better if you have a higher forage in their diet versus the other, based on what you can see in their gut. So the main technical challenge that we have is that these are time consuming and pretty costly approaches right now. And in order to bring that for use by the farmers as a tool, we need a lot of work to be done in terms of cost and time to results, automation of data analysis, reporting. So I am participating at this ICDS symposium today, looking for funding opportunities and collaborations. Specifically, I'm looking for collaborators that are willing to work with me on the development of animal health, production, or animal AMR-focused data analysis and decision-making tools. Thank you very much for your time, and I look forward to hearing from you.
As we look at our faculty members, and I want to make sure to specifically thank Dr. Hillman, who has been great in not only putting out some great research, and Ryan, you can prime his video, but Dr. Hillman actually helped put on this conference today. So this presentation is personal, because without Dr. Hillman, we wouldn't have had a lot of the things in order today. So Ryan, you can start this one up, please.
Good afternoon, everyone. My name is Mike Hillman. I'm an assistant professor at Penn State, and today I'm going to talk about direct image-based numerical simulation. So that is the objective of this work, is to take images or scans like CT scans, MRIs, and micro CTs, for instance, and convert them into models and directly do numerical simulation in a seamless manner. So the reason that you would want to do this is to build realistic models of your system at hand, whether it's a structure or microstructure, and gain insights into the physics, for instance, or the mechanics of this system that you're interested in. So obviously this spans across disciplines from bio to anthropology, aerospace, mechanical, civil. Anytime you're doing scans of materials or structures to do your investigations. So there's lots of different applications of this besides just looking into the mechanics or the physics of the problem at hand, obviously. And the motivation for this topic or this research is that if you have a CT scan in hand or any type of scan in hand, it's very difficult to build a numerical model out of that scan, out of that image. Now, the reason for that is that typically to do the analysis, you would build a so-called mesh to do the analysis. And building that mesh for very complex geometries and microstructures is very difficult. In particular, it's very difficult to build a high quality model to get accurate results. So the research that I do in my group is develop what's called mesh-free methods that circumvent this issue by just using a purely point-based discretization. So no meshing at all. You can take the image after some segmentation, take the pixels and do direct numerical simulation on that image because the method is just pixel-based or voxel-based. Okay, so here's a simple analysis of the stress field of a micro CT just using the pixels. And here's a more complex analysis, and this actually demonstrates the flexibility of mesh-free methods, which are very adept at doing damage and fracture. Okay, so obviously there's technical and commercial risks in terms of whatever physics you're trying to simulate. That could yield a very difficult problem, and you have to develop new methods for that. And of course, there's a little bit of uncertainty with the time frame for developing those methods. The resources required for development would be student support. So thank you for listening to my talk, and goodbye.
Just as our ROAR system through ICDS links up to Dell, IBM, AWS, all the other industry groups that we tie into, so do the individual Commonwealth groups link up to our system as well. We don't just work with UP areas, we work with all of Penn State throughout the entire state. Brian, if you want to start the next video, please. This takes us into one of our Commonwealth researchers.
Good evening, everyone. My name is Abdullah Konak, and I'm an IST faculty at Penn State Berks campus. This evening, I would like to talk about a project that I have been working on over a year now. The project is about student retention. Student retention is an important and a current problem in many higher education institutions. In the US, 1 in 3 first-year students won't come back for the next year. Retention rates in STEM fields are also lower than the national average. Unfortunately, colleges catering underserved populations also have lower retention rates. To increase retention rate, colleges offer a variety of support programs, including tutoring, freshman seminar courses, peer mentoring, faculty-to-student mentoring, student-to-student mentoring, etc. These programs aim to keep students engaged in their education and involved on campus, as well as increase their academic readiness. Despite all these efforts, student retention continues to be a prevailing problem. The problem is difficult to solve, not only because of the complex socioeconomic causes, but also its behavioral roots. This project focuses on behavioral aspects of the student retention problem and proposes an innovative solution grounded in the recent research on persuasive technologies to change attitudes and behavior. The goal is to increase student engagement in existing retention programs, not to create one. We will develop a tool called Reset for Success app to gamify student engagement in retention program and collect data and analyze it to identify strategies that work well and do not. I received a positive feedback from National Science Foundation when I sent a white paper about this project. However, there are some challenges that I need help. The first is to have a working prototype before asking for funding and scaling the system if it's a promising approach. Additional collaborators and a support from an outside partner to develop this prototype and to help in scaling it will make the proposal more successful. Thank you very much for your time and listening.
So far, we've been talking in traditional academic terms. So College of Science, College of Engineering, Commonwealth campuses. And the one thing that ICDS works really well with is an institute where we bring a lot of people together. We work with other institutes. And with this here, you can see with the Applied Research Lab, what we're doing here is combining work with other institutes and really working across all areas of the campus. Brian, if you want to start the video.
Hi, my name is Stephen Nixon. I'm a research and development engineer with the Applied Research Lab here at Penn State University. And today, I'd like to talk to you a little bit about how we at ARL are using data science to push the boundaries of condition-based maintenance. Now, condition-based maintenance is the practice of only doing maintenance on a piece of equipment when you have evidence that maintenance is actually required. And it's an alternative strategy to reactive maintenance, which is only doing maintenance after a system has broken down, like when you change a burnt out light bulb, or preventative maintenance, which is the art of only doing maintenance on a predefined schedule, like if you change the oil in your vehicle every 3,000 miles. Now, the benefits of performing effective condition-based maintenance are very high. By scheduling your maintenance at optimal periods, you can lower your downtimes, increase your equipment's availability, and reduce your overall maintenance costs. But effective condition-based maintenance, otherwise known as predictive maintenance, is entirely reliant on the ability to make accurate assessments of a machine's health. Traditionally, these health checks require expensive sensor equipment and specialized training. However, we at ARL are investigating how these failure predictions can be made in the new world of big data. Many pieces of equipment that are manufactured today, from the cars that we drive to the equipment that our government buys and relies on, are equipped with an extensive sensor suite, which collect a lot of physical state variables that are used by complex control systems on these pieces of equipment. Many asset managers are now asking whether or not the data being collected for these control systems can also be used to make accurate health assessments to enable condition-based maintenance. Now, some of the challenges that we face. The goal here is to infer the health of a piece of equipment without access to a dedicated, targeted health assessing variable, which makes it difficult. Data is often of very poor quality and can be very limited. Regardless of how many gigabytes of data somebody may have, there can be very few examples of breakdowns of that specific piece of equipment, making it very difficult to predict those breakdowns. We also face a very high bar for explainability. Successfully transferring this technology to a customer requires non-technical users to completely trust the condition assessments being generated by the system. I'm speaking to you today because we're looking for collaborators who are excited to work on this problem with us. If you're interested, please reach out to the email address listed at the top of this slide and shoot me an email. Thank you very much for your time and enjoy the rest of the lightning talks.
Today is a snapshot of what ICDS has. Like I said in the beginning, we have about 10 researchers that are presenting today. One thing you should know is we have about 3,000 people that actively use our system. So in terms of what we can do in our system is really only held back by the questions that are being posed. As we look at this next presenter, again, it comes from one of our Commonwealth campuses. But the nice thing you can see here is we're using a lot of outside data that comes in from a industry group and community group that's wanting us to do some research for them. Ryan, you can start.
Hello everyone, my name is Dr. Sabahattin Gökhan Özden. I am from Penn State, Abington. So the main objective of this talk is to introduce an information system about an opioid overdose death database with the collaboration of Montgomery County Coroner's Office. Montgomery County Coroner's Office has historical data about overdose victims since 2000. However, most of these historical data are paper-based, unreliable, and hard to analyze. We developed an information system using a relational database to easily collect this data in digital format. Since 2007, we have spent over 2,000 man-hours for development and over 4,000 man-hours to digitize more than 5,000 forms related to 488 overdose victims between 2011 and 2015 period. The current information system has over 150 database tables, over 2,000 attributes, and over 1 million data points. We intend to use this information system to replace paper-based forms used in coroner's office and in related government organizations. The system is cloud-based, managed by Penn State, and can be really easily extended to other Pennsylvania counties. Penn State faculty who are interested in opioid overdose deaths can also access this information-rich database. This project was supported by Penn State Abington Chancellor's Grant, Penn State Social Science Research Institute, and Penn State Justice Center for Research. We are interested in collaborating with data scientists, medical researchers, and faculty. And we are also seeking support from government organizations for implementation, as well as industry for technology support. With more support and collaboration, we can learn more about the victims, patterns, and relationships, and better fight this epidemic and save more lives.
In addition to the Penn State faculty research groupers that we also bring in a lot of research groups from other institutions, both nationally and internationally. Ryan, if you want to set up the next video, we begin to look at work that we did with Yellowstone and also bringing in Twitter data, bringing in a lot of different groups into the research piece here.
Good afternoon. My name is Penn. I'm associate professor in recreation park and tourism management in Penn State. I'm going to talk about our study on mining and validating demographics and experience of Yellowstone National Park visitors from Twitter. This study was done with my colleagues Yun Liang, Jun Yin, Guangqing Chi, and a few other people. Our research is intended to study what demographic information and experience can we learn from those tweets of those people who are visiting Yellowstone. Do those tweets represent Yellowstone visitors in general? We are doing this study because surveys are the traditional way of collecting data from national park visitors, and we know they are very costly to implement. They can pose biases depending on where do we approach the visitors and who do we ask those questions? Can we use social media data to complement or even replace surveys? Thus, we compare the tweets results with surveys. Machine learning can give us a way to obtain demographic information from either user profile or their tweets, and also their sentiment when visiting the national park. However, we are facing a few challenges. First, the mobile phone access inside Yellowstone is very limited because of the requirement for natural resource preservation. Thus, the tweets we obtained are very sparse. They only appear in few places, such as the old Facebook geyser and the lodges. We all know Twitter data could be a biased population. Our result shows the Twitter users in Yellowstone are younger and with a higher level of education we compare with surveys. In addition, only a small proportion of tweets are geotagged, anywhere from 2 to 5%. We also found out the most tweets are about positive experience of visiting the national park. The negative tweets are rare. Only 7% tweets actually are negative experience. Also, there's a long way from their experience to really service quality measurement. They talk about their visitation, but how do we translate that into the improvement the management can make on their service? Thus, there's opportunities. We really need to obtain more data beyond Twitter, such as Instagram data, Flickr, mobile phone location data. Now we can triangulate those data sets to get a better idea about visitors and their experience in the national parks. Those combination of data can provide cross-validation. And for machine learning model to work, we really need a larger data sets. We can train the machine learning model to figure out the service quality improvement. So that's opportunity for further research. We're really looking forward to talk to our colleagues here at Penn State and beyond.
When we look at everything we've been presenting today, one thing I'm hoping everybody can see is with ICDS, researchers look not only at current issues, but future issues where the road hasn't even begun to bend yet, and they're already looking at problems that are going to be happening and solving issues in the future. As we look at this next one, and Brian, you can move ahead to prime the video, we begin to understand in an economy-based system, where do we move forward from?
Hello, my name is Vital Prabhu. I'm a professor in industrial engineering. Today I'll talk about our view on engineering the 21st century service economy from the perspective of data-driven decisions in service systems. As we know, the service sector is fairly vast and represents over 80% of the economy, with industries that are quite varied in terms of their information intensity, as well as the quality of service they provide and the productivity that they experience. So what we feel is that if we can provide good tools for making data-driven decisions that are well engineered and easily accessible by the management, then we can significantly improve the productivity of the specific industry at hand, as well as the overall economy. So that's why we are investigating opportunities for data-driven decisions in service systems. We worked on a number of problems in and around Penn State, and the chart here shows the productivity improvement that we found in these specific projects and the data availability. As you can see, it ranges in terms of from 20% to 50%, and data availability can range from fairly high to pretty low. For example, in food services and landscaping services. So what we found through our experience here is that there's a pretty acute shortage of human capital in terms of engineering talent, managers who understand both the domain as well as the nature of data-driven decision-making, the algorithms that we can employ and the techniques that we can employ. The main unknown in my perspective is that getting the management and the stakeholders to understand the potential for business impact, and from a technical point of view, to be able to provide them with tractable models that provide insights on how they can improve their processes, as well as make a business case in terms of return on investment. We have a tremendous opportunity. Students are pretty enthusiastic at all levels, ranging from undergraduates to graduate students. If we can provide them opportunities in terms of authentic context and some funding to validate our research, I think we can really engineer the 21st century service economy. Thank you for your attention. Look forward to hearing from some of you.
As you heard in the last presentation, in addition to the 4,000 researchers that we have in our system, we also have a lot of students that are in the system as well. Postdocs, graduate students, undergraduates, student groups, class projects. And what our work does is really gives an educational opportunity with high performance computing in the research that we're doing. We're going to end here with our last presentation. And Ryan, if you want to get this set up, and then we're going to talk about what the interactions with faculty look like afterwards.
Hello, everyone. My name is Meng Su. I'm an associate professor of computer science and software engineering at Penn State, Maryland. My talk is about an innovative new course. We developed it and offered it as a special topics in the last few years. Currently, as a formal course, Computer Science 445, Applied Machine Learning in Data Science. The values include bridging the gap between industry trends and college class in AI areas, engaging students in using industry cutting-edge AI tools and platforms, and introducing various aspects of applying machine learning to solve real-world problems. In summary, I use this diagram to illustrate the value of integrating the three elements in this course: academia, industry partners, and customers in all areas. Challenges are we want to build applications that have an impact on the industry, such as marketing and sales, education, and other industries. They need domain knowledge in the area. They need teamwork. I list a couple of sample projects students did originally from this course. The first one, Professor Nittany, is a virtual advisor for World Campus students, which won the Nittany Challenge Award a couple of years ago. These two are our students' senior design projects. Left one is a chatbot agent for a local company. The right one is to use social media data to monitor the weather and other climatic events in real time. It's sponsored by Area Insurance Company. Risks are that we need to keep pace with rapid updates and trends of the technologies and products in the industry, including artificial intelligence tools, platforms, standards. Another risk is the acquisition of data, data integration, data scale, data security, and related policies. We want to seek more opportunities to support this course, including sponsoring our projects. The left diagram is a management framework of our senior design projects. Hiring our students, presenting in our classroom as guest speakers, and providing free cloud-based environments and tools for the class. Thank you very much for attending my presentation. Please contact me for any questions, and my email address is my name, mengsu@psu.edu. Thank you.
That concludes all of our faculty talks. In terms of next steps, some of our faculty members do have availability to engage with them more if you have other questions about their research. The link that I just posted in the chat will give you their specific breakout rooms. Some of the faculty aren't able to be there, and they're allowed to, they've asked you to be contacting them via email. Tomorrow at 8 a.m., we start our tomorrow session. We have a keynote starting right at 8 a.m. We're going to be looking tomorrow at the Office of the Director coming in from the National Science Foundation in regards to Convergence Accelerator. And we have some great sessions tomorrow about social engineering in terms of destabilization of the political order, and also genetic in data and genetics and DNA. So without further ado, I want to say thank you for a great first day. We appreciate everybody. Again, a special thanks to our sponsors, AWS, Intel, Dell, VMware, IBM, and everybody who's come in today with all the panels. We really thank you all for your time. And it's been a pleasure to have you all today. Thank you.